Alright, so back to the injection molded parts. So got the core and cavity printed out. I've made a few changes to the design since the last one that I filled, this one here. So I'll come back and show you what the differences are, but I'm not using this guy. I've printed new versions of him. So I've got my epoxy here, and I've got my scale. And this epoxy, well, besides this epoxy is nasty stuff. So there's always the question, kind of what's the right amount of epoxy to use. And the amount I need is I'm going to have to mix out 340 grams of this part A, and then another 40.8 of the part B. And that will mostly do what I need. It'll probably give me a couple of milliliters extra. So how did I come upon this number? I basically had to go back to the STLs. And I'll go back to the original filled version of the mold, and I got the volume of that. And then I found the version of the mold that had all the internal supports, and computed the volume of that STL. Mesh mixer, planar tools will do it for you. And then subtracted the two, and that is the amount of space still left inside of the part. Now that I've hollowed it out, and it was significant, right? Because the volume of these parts were originally somewhere around like a 200 or so milliliters in volume, and they're reduced down to about 100. And so once I found the amount of volume that needs to be filled, then I can go to the spec sheet for this EpoxAcast 655 to come up with the specific gravity number of grams per cubic centimeter. For this, it's 1.6, and that means that I needed 340 grams net, plus a little extra because that doesn't include the 12% of this. So I could have reduced that down, but they only have the specific gravity of the combined and not the separate. And I do know that this stuff is way denser. So I will have a little bit of extra, but this will give me the amount that a pretty good ballpark number. This stuff is real thick to stir up. I want to stir it up to make sure the aluminum particles didn't settle. This viscous stuff, it doesn't settle that much. And then I'm going to want 340. So I'm at 287, 290, 306. $340. Oh, that was pretty lucky. 340.4. Let's try not to get any on my scale. That would be sad. This is a scale I got from on a Kickstarter. And so that's 340. Then I'm going to need 40 of the hardener. Let me scrape off my stirring stick. Big enough stirring stick makes a huge difference. Last time when I filled this guy, I used this for the stirring stick. This is too wimpy, way too hard. This, nice. Big bamboo stick that I got for, in this because I could have probably found scraps somewhere, but I bought it for $1 at Tap Plastics. And I feel it was well worth the money. This was way easier. All right, that's 340. Oh, got some on my gloves, got some all over. Yay, messy. Well, that's just the way it is, right? Okay, close this stuff up. So that's it for the part A. And then the part B, the hardener. I want 40.8 of this stuff. Tear it down. This of course is way thinner. This stuff is way more noxious. It's not extremely noxious, but it does smell a little bit like chlorine. So you want to be careful with it. I've got safety goggles on. And so I want 40.8 of this stuff. There we go. 40.8. All right, so that's it. And then what I used to wipe this up, this was nauseous, throw that away. I've added plenty of shop towels to my kit now. There are just some things that I cannot, that are better to just kind of soak up and throw away rather than try to wash out. Alright, so that is done. Get this out of the way. And then mix. Back to the sturdy stick, I suppose. And the reason why the sturdy stirring stick is good is because this stuff is viscous. And so the sturdy stirring stick, even in a smaller amount, it's easier to control it, because then it's not flexing. The addition of the hardener then thins it down. And while I have some like non-disposable containers like this guy here for mixing epoxy, disposable containers are in order. You're not getting whatever this is never coming out of the container. We got to get this mixed quite well. I want to turn this upside down so anything extra drips out. And And then it's a little bit tricky because, yeah, this is a double dose because, or rather, this is the dose for the full set. It's not 340 just for this guy here. It's 340 for both halves. The other half is up here, still on the printer draining. And so I'm gonna have to be a little bit careful when pouring to make sure that I don't overfill. Okay. All right, so what's our setup going to be here? I've got the part, which I'm going to leave on the build plate because I don't want any risk of the part warping. And I'll talk more about kind of what I'm doing here. I need it propped up, so it's still on the build plate. I want to prop it up. This nice heavy container here is good for that. You know what? Oh, I'm gonna do it this way. A little bit like this, so this can be flush against, and this build plate will be tilted a little bit. All right, and then I'm gonna stick this in. There's some support inside there. I'm just gonna push through the support, and okay, I've got this on here, and that should be fine. And so what I did was, I'm really worried about shrinkage. That would mess up the dimensions of this thing. So after I finished printing this half, I just kept it covered. There's no UV in this room, but just in case. And then I only just now lightly rinsed it with IPA. And while I was rinsing it, I was checking for leaks. And it looks like the only possibility for leaks is up in this top part here, where I have a bunch of this extra support on the stationary end to reduce any likelihood of separation. So the profile looks pretty good, and I know there's no leaks anywhere else. It was a little bit difficult to tell whether or not there was any leak down there, whether just I wasn't effectively stopping this hole when I was testing. Right? There's two holes. There's a big one, and there's a little one, the air hole. And when I see epoxy coming up out of that, then I know I'm done. There'll probably be, by the time that happens, epoxy will be coming out of the main hole too, so I'll have to be a little bit careful. And so there might be some leaks at top, but it is at the top. It's not at the bottom or anywhere else. And so that's okay. Hopefully. And then I will pour in one dose. First one will be easy. Can't really see that. The first one will be easy because I can just fill the funnel all the way up. And then screw the side, and then set that down. All right. Then we let this drain down, and it is draining. You don't really need to look, but just in case you're curious. Be a little bit careful so don't spill. It's better if you don't check. Right, you can see that it's draining out the bottom. There's a little stream here coming out, just flowing real slowly, which is okay. So okay, let me get this back in, and this will fill the part. And just repeatedly put funnel fulls until we get epoxy gushing out the top. So we'll say why I ended up redoing it. So my previous part was like this, right? I had 2 fill holes on the profile side like this, and the problem is that the lifting was still a bit too much. I didn't have the protective supports here, and so there was a whole bunch of separation, and it kind of leaked all over. So I had leaks coming out of here while I was pouring epoxy, leak coming out of here, and I had this little tube of crazy glue gel that I was using to try to stop up the holes. And it's kind of interesting because the epoxy or the hardener does cause the crazy glue to instantly harden, so I eventually did win. And then after, you'll notice it's still on the build plate, right? And so it was still on the build plate. Then I had this bit here that I'd have to Dremel out, and that was okay. And then the resin shrank a bit over the weeks because I did this like 3 weeks ago. Formed a few cracks, but none in really critical areas, none in this diffuser area. The big problem is that this was a long time ago, it was like 3 weeks ago. And I don't have the matching part. And since then I fiddled with the calibration settings a little. And since the 2 halves need to fit together exactly, there's no guarantee that the mold core, which is what's on this build plate now, would fit onto this cavity. So after I printed out this core and got a good feel for the settings and got a really good run with this core, I printed out another cavity, and that's what I'm going to use instead of this. And there are some design changes. Instead of having the holes on the side here, the holes are now on the top on the side closest to the stationary end. And this is where most of the damage occurs. Structurally, the part under pressure, right? The strongest part needs to be here in the center. And so if I can print it nicely and there's any gaps over here, you know, that's at the same level as the holes. And so once I see epoxy coming out of if there's any gaps here and they start gushing out, I can just stop. It's not like having a gap way down here, where since I was filling from the top and there was a gap at the bottom, then oh no, it's gonna keep on running. And I managed to avoid getting any of those side gaps. So I double checked, no gaps here on this part, no gaps on the side, so no problem. Because this stuff is, it seems viscous, but it's thin enough that it'll come out of any gaps that you have. And so this one is kind of a sample. It can be finished, right? Again, right? You slot the 2 halves together. This interface here is totally fine, right? This part is flat. So you slot these 2 parts together. I'm gonna put the sprue bushing. I'll show you the sprue bushing. All right. The sprue bushing is like this. This rounded divot is where the ball head of the injection molding machine of the Morgan press is going to go. It's going to shoot plastic in here, and then this sprue bushing distributes the heat, so I don't have the 10 tons of the press pushing down directly onto the resin, and concentrating that heat onto the resin. Instead, I've got the bushing. This will distribute the force, and then this round here, right, it's going to come on the other side, and this is going to fit right in here. Flats cut here so that I can kind of rotate this guy to get it out, and then I'll have to drill a hole right where there's this divot there, or rather there's a kind of a countersink that's part of the design, a starter hole. I'll be able to drill a thin hole all the way through, just in here, this is kind of a tester. All right, I don't have a gate and runner system. The gate flows directly into the part. I don't have a cold well because hopefully this is big enough that I can push around it. It's pushing into by putting the hole here, it's going to push into space where there's three-dimensional space all around. Hopefully I'll be able to live without the cold well. And so this will, I'll drill a small hole to be the gate, and then all the way through, and then I'll probably put a hole that matches. I think this was an 1/8 inch. I'll double check. Put a hole of this size, probably put it down for the first, make it only maybe 2 millimeters deep, just so that it'll match, and so that there'll be like a taper from the taper of the drill bit that'll lead into the narrower hole that'll go in. And those should be pretty easy operations. Pretty easy to go in one small drill bit and a bigger drill bit on the drill press, or on the clamp that's down in the milling machine. So that's the plan, and we should be close to being able to execute on that. And so we got this going. Yeah, so it's definitely going down. All right. Again, it's not going down super ultra fast, right? Whoops. Oh no. Don't mess with it. So I'll put a little more in the top now, so that be a little bit more pressure. All right. A bit of the drill. Put this down. And we'll just let this keep going. And that's pretty much it. I fill these and then leave them on the build plate until they are filled. So I've got a core here. I've got the old cavity I can use in case I fail with the new cavity. The new cavity is right on the printer. Hopefully printing these in rapid succession. This guy's maybe about 12 hours older than the other one. Will prevent any shrinkage issues. And then I'll try to avoid getting epoxy onto the build plate. Again, it's not the end of the world. Rougher build plates are better. And these build plates are anodized aluminum. They're super tough. But it certainly would be better to keep them a bit cleaner. I did get some epoxy on one of these build plates the last go around for this guy. It was no big deal. The quality of these parts here now is a lot better. It took about 4 hours and 20 minutes for the core, which is a little bit taller. It was about 280 or so layers. And the cavity was just under 4 hours, like 3 hours and 50 minutes. Just 10 millimeters per minute of lift all the way through, and exposures. The trick, like I said in the previous summary video, is that I did have to print on bare silicone. And one of the things that I had to change to improve my yield and reduce the issues that I had here is I had to increase the exposure time. Increasing the exposure time does come with some additional problems. Normally when we print on the regular PSP vats, we are not printing on bare silicone, but rather, right, there's this nice piece of film on top of it, and this film is great because resin doesn't react with this film. And so if I want harder, I can pump up the exposure time. I want more hard, or if I have corners that aren't curing, I can just pump up the time and run the whole thing at the maximum speed I need for any particular part. And so long as I have some pigments prevent overcure, no problem, is pump up the power and don't worry about things. And that's great. I love printing on the Titan 1's PSP vats for that reason. There's really, not much to worry about. The problem with the plain PSP vats, at least, is just that the silicone is much less sticky. And so, and I have some pictures that I can show you. It would be great if we could get the less stickiness of silicone in combination with the strength of the sheet, but I can't, right? And so, with silicone, you got to be worried that you're going to burn in the silicone. And so I did have to do a mask. I'll probably describe it on the forum some more. I did have to put in a projection mask so that I could get the corners or one far end cured fully without burning the front end. Burn the front end would basically cause the part to stick to the silicone because of the chemical reaction between the resin and the silicone, that it's then extra energized from the extra light. And of course the stick is what I'm trying to avoid. And so I have to be able to pump up the power in the corners or in the end closest to the stationary end and pump up the power for that enough, but not have the center end up getting burned, which will get the part stuck and cause a print failure. There's a video of this online also. And then so I did need to eventually deal with the projection mask and apply a mask to dim down parts of the image so that it's all kind of relatively even. And that probably was the trickiest part in software that was necessary to get this part out. So we just let this go. This is pretty boring, so I won't bore you by forcing you to watch this.